Say hello to Cedric. This is Cedric. Cedric is a little chap to whom I explain things that I don't understand so that I can understand them. Isn't that right, Cedric? Yes, it is. And I'm going to explain to you today the holographic principle, which is actually quite interesting and rather terrifying. It arises out of a controversy that raged for something like 12 years, I think, around the nature of black holes. Because Stephen Hawking, doing the math on black holes, suggested that information disappears into the black holes, yes, which we knew. The information goes into the black hole. We can't get it out because the black hole's sucking everything in faster than the speed of light. So we can't get, by definition, can't get any information out of the black hole. You understand that? Yes. But we do know the information is still there. So the information is not, mathematicians would argue, lost. It seems a little paradoxical to me. Information disappears somewhere where you can't get to it, but it's not lost because you know where it is. It's in the black hole, although you don't understand the insides of black holes at all well, because no information ever comes out of them. But you see what I mean? The mathematician says, oh, well, the information is still there. There's a fundamental principle, apparently, that information is not lost. So it goes in the black hole, you can't get at it, but it's not lost because you know where it is, it's still there. Fine, until Stephen Hawking comes along and says, yeah, but you know what? Black holes eventually shrink down to nothing. So where's your information then? Okay, this is a bit of a teaser, this one, because this had them boiling. Yeah, the information disappears into the black hole disappears, the information, well, you still know where it is because it's in the black hole, but the black hole's not there, so actually you have to face the fact that the information has disappeared, and that's, according to all the known laws of physics, that's impossible. You agree? Yeah, well, of course, until the holographic principle is invented, that might be the word, discovered, one might say, but now regarded, I think, as the universal truth. Let's see how that goes. Information in the black hole doesn't actually go in the black hole at all. It is sustained around the event horizon of the black hole. That's the theory. So presumably when the black hole disappears, the information is given back to the universe. Now, it's interesting to think what we mean by information here. My understanding is information is everything you need to know in order to make a complete reconstruction of something. So if you disappear into the black hole, you're gone. I can't see you anymore. But the information to recreate you in every possible detail subsists, we now think, on the event horizon of the black hole, if I'm understanding this correctly. If you're understanding this correctly, I hope we're both coming to some sort of understanding about this. Now, if that is the case, and it seems that if we are to preserve the preservation of information theory, which is fundamental apparently, it must be the case that the information is retained on the event horizon of the black hole. We can derive, mathematicians who know a lot more about this than I do and can do all the squiggly figures and so forth, know, they are able to show that there's a generalized version of this principle, which is what we call the holographic principle. And it works like this. You take any sphere in space, a notional sphere. Imagine a sphere. It could be this size, could be the size of this room, could be the size of the entire universe. And the principle is this, that all the information inside that sphere, and by information, of course, we understand ourselves to mean everything you need to know to recreate that, what the matter, whatever is in this sphere. All that information can be encoded on the surface of the sphere. And from this, we start to have wild ideas that maybe what's inside the sphere, what appears to be inside the sphere, isn't actually there at all. It's all just a holographic projection of the information which is now really on the perimeter of this sphere. And this sphere, as I say, can be any size. The sphere, you can imagine a sphere which is the size of the known universe, and you have to be careful here. The universe is expanding very rapidly, and at the edges of the universe, at least the edges, what we perceive as the edges, and you'll understand why in a moment why we perceive them as edges, the universe is accelerating at the speed of light. So although there's almost certainly more universe stuff beyond that point, we will never get to it. It is a kind of black hole situation in reverse. So we will never get to that. So we do perceive an edge to the universe, literally as far as the eye can see. So we've got this edge to this, and that is a sphere surrounding the known universe. And according to the holographic principle, you're still listening, I hope. Yeah, your little beady eyes are paying amazing attention. Look at that. Paying attention. So on the edge of this thing, we have all this information we need to know to recreate the stuff that's going on inside the universe. And the corollary of this is that actually we don't really exist. The planets don't really exist. They're not what we think they are. These are all just holographic projections of the real stuff, which is a bunch of mathematical functions encoded onto the surface of this edge of the known universe. So that's where we are with the holographic theory, if you've followed this so far, and I almost have, I must say. But there's another twist to it, because we're talking about a sphere embracing space. But of course, we now know, at least as devotees of Einstein now know, that there's no such thing as just a space. We actually have to call it space-time. And we're not creating a sphere around three-dimensional space and projecting it onto a two-dimensional spherical surface. We're actually taking space-time and creating a sphere around space-time, and therefore encoding it onto what I suppose we have to call an n-1 dimensional surface. However many dimensions there are in what we're calling the sphere, these are projected onto an n-1 surface, which is what's surrounding this area. So who are we? If there's anything true about this, and I see you are thoroughly gripped. If there's anything true about this, who on earth are we? Are we and our possessions and our friends and the houses we live in and the planet we live on and the planets we hope to go to in the future, all really nothing more than projections of these mathematical functions which are on the edge, encoded onto the edge of the universe? And there's a corollary of this too, that if indeed that's what I am, encoded onto this n-1 surface, that contains my timeline as well. In fact, not just my timeline, but my entire evolutionary timeline. In other words, the tendency that I have from time to time as I brush my teeth or whatever I'm doing to think, oh, this is a habit that has developed as a result of a long evolutionary process handed down from father to son, from mother to daughter, and here am I cleaning my teeth because evolution has taught me it's the right thing to do. But actually, according to this extrapolation, I suppose you'd have to call it, the holographic theory, I'm not the result of that evolution. I am the entire process of evolution. And I'm not here, I mean, I'm a complicated set of mathematical functions encoded on an n-1 surface so far away that I couldn't even possibly dream of ever reaching it, however far I evolve. And I have to say, this gives a whole new slant to my cleaning my teeth in the morning. What do you think about this? You got any thoughts at all?